Hey guys, so today you and I are going to talk about integration tests for distributed systems. So let's get into it. So the question in question was, hi Frederick, how do you write integration tests for distributed systems that won't be flaky? That is a good question. So I usually promote to people to consider just what it is that usually makes an integration test flaky. So on average, the problem with an integration test is that if you run it as if you don't do like a real end-to-end more of an end-to-end test type of thing, where you actually have like your own environments, you have a production like or QA environment and so forth, and you run all these things, and you sort of have these independent interfaces for different services that connect over like across teams and so forth. The flakiness that you are referring to depends a lot on the architecture of the system that you are dealing with. So what I usually tell people is that I don't think it's a good idea for you to write these sorts of tests if you can avoid them when it comes to the live environments themselves. It's not because I don't believe integration tests, it is because I believe that the inherent problem with running end-to-end tests across a very large distributed system is that you will, unless you know what you're doing, create state that you will not be able to deal with. And as you said, it's going to be very flaky because you basically need to be in a state where that you as a developer, you have to sort of be able to trust that the quality of the different services are in a consistent state, because otherwise these things are going to start failing, and you more often than not are going to figure out that you spent an enormous amount of time trying to just maintain these tests. It's the same thing when you have a large amount of end-to-end tests for like the UI layer, where selectors are not found or something like that, where you're just trying to maintain the test because the test is, as you were saying, it's just flaky, but you're not getting much value from it. So what you want ideally is to figure out where can an error actually occur, and focus on doing that instead. So for an integration test, let's say that we have a few services that are going to talk to each other. Now, two things are ideal for when you're dealing with this. One thing is if you have like your own service and you identify that it's going to connect to some other services somewhere, you usually have two approaches. Now, the one that I favor is to use contract-based testing. And contract-based testing, for those of you who don't know it, is very simple. It's literally just checking that your expectations as a client to another system, like that the API specification that they have is consistent with what you expect on your side. There are tools for this, but a lightweight thing that you can do, which is basically on the provider side of this connection, is that they write their own integration test towards their own API as part of their development process, where they have, like, you set that as a rule for all your systems, that each and every system has to provide an open API specification or something similar, and those open API specifications have to be version controlled, and they have to have associated integration test towards the API itself. The thing that I usually like to do is to have a runner as part of the service, where basically and I usually use I advocate very strongly for having the service owners provide client libraries. You can generate basically, that's my favorite one. If you can generate, that's the absolute best thing. You can generate REST clients or gRPC, if whatever you're using, right? Or GraphQL, if that's your thing. Those client libraries, if you can generate them and put them in a library that can be consumed by whoever is depending on your service, that's the ideal case. And then you use those API specifications to create your test bed, because it is the service provider's responsibility to maintain the contract. There are more advanced versions that you can use of this. One that I think is pretty nice is Pact, for example, where The client can write their own expectations, and that creates a reference file that the service provider can use to basically run their own set of integration tests on their side and validate that they pass when they actually connect to databases and so forth. The reason why this is very powerful is because you're basically just betting on that as long as the contract is true, as long as the specification is true, then it is on the consumer's side, the service provider's responsibility to make sure to not break that contract, which is sort of the thing that you do whenever you integrate to any API, because you as the client, your problem is that you can't really do much if the thing that you are depending on isn't actually working. So when you create an integration test, you basically have to treat that as a black box, because you can't really know how it's going to behave. The next best thing you can do, which is if you have a smaller integrated system, like a distributed system, maybe you just have a few services, is that you basically have a test bed of these sorts of integration tests that you can write that depend on those services working on, say, your local laptop. That's one that I've used in smaller distributed systems where it's not like super connected, where, as I said, all you really have to do is to say, if you're using Docker Compose, like that's one of that I like. You basically containerize all your applications, and then you can, in your test runner, basically spin up the services, connect them to your local test runner, and then run them. Because now you have like the databases and everything set up, you can actually set that up so that it works fairly seamlessly for mid-sized, small-sized-ish distributed system. But for the larger stuff, as I was saying, it becomes impractical when you might have, systems that you can't actually put on your local laptop, or like the third-party services that are like some external API that you can't really do much with. And so when those sorts of situation happens, contract testing is my favorite approach, because, as I said, it's the agreement that you can make with another service without having to run fairly flaky integration tests. And then I suggest that you have a very small set of smoke tests for like integration tests, which is what I usually promote to people when it comes to end-to-end tests and so forth, where we can talk. There's a different video where you can talk about testing in production and QA environments and so forth and so forth. But basically those tests are just as I like to call, focus on the stuff that always has to work, and simply write a very small set of tests that actually tests the end-to-end flow, where you're actually doing the thing that you're supposed to be doing. I don't have time to go into how to do that, but the flakiness that you're talking about usually is a symptom of either very poor architecture, and if you have that, there's no way around it. Then I suggest you just fall back on the contract testing, because at least the contract testing will be stable at all times. But the other thing that happens usually when you get a lot of problems with flakiness is that you have so many tests that flakiness is almost inevitable, because the more tests you have, the more likely you are to have these one-off issues with network issues, like these things that just, they happen once in a moon, but you have so many tests that it's going to happen frequently, and you can reduce that down to almost like have a very stable system if you just realize that the testing pyramid that you may or may not have heard of should be applied here, where your confidence in that the system works should be established much earlier than the top of the pyramid, where the integration tests and the end-to-end tests are happening. And at that level, you should only focus on what basically tells you if the system is completely broken or not, like those core features, because then you have a very small peak of the pyramid that just validates that the overall rough stuff is working. And that basically means that the flakiness is almost a non-issue, because it's not going to happen all that often when you have such a small set of tests. But your confidence should still be there, because you're covering your basis with contract-based testing, which should cover most of what you need to do. So what I want you to take away from this is that the way that I suggest that you write integration tests for a distributed system so that it's not flaky is, number one, make sure that if you just have a small system, run it locally, because usually taking into account like everything that can go wrong with firewalls and so forth, if you run all your tests like for everything that you can do within the system at like an environmental level, it becomes enormously complicated for you. You can get very far by just basically reproducing, if you use Docker Compose or something similar, where you can basically spin up a good enough version of your integration tests locally on your laptop. For really large systems where you might not even be able to do that because you have third parties and so forth, then I suggest that you take a look at contract-based testing instead, because that system of testing basically is you making sure that the client and service providers are agreeing to the same contract, which is the thing that you should always be able to trust. So if the providers can provide you with a library, or make sure that you have a version control OpenAPI specification that acts as the base for the contract, and that the providers make sure that they actually are compliant, so they don't introduce breaking changes or anything like that. And as I said, ideally they have a library that they generate for you. That is a very stable and efficient solution for you to use. You can look into Pact, for example, which is one thing that I think is a pretty useful setup as well. But that at the very least will scale even to the really large sorts of systems that you might be dealing with. And then, well, we could talk about test bubbles as well. So an example would be if you like this, now it gets really advanced. I don't suggest that you do this unless you have like a really critical third-party system where you can't do contract testing, you can't do anything like that. But basically that's when mocking and stubbing comes in, where you might have services that you depend on, where you can monitor the traffic, where you're looking for, say, production data, and you make recordings of how a system behaves at a given point. You can record the responses that you get for certain payloads and then stub off the the external service in your integration test and simulate what would happen if this thing happens. The problem with this is that you can start tricking yourself, because if you start mocking too much, you're very quickly gonna. This is why the contract testers are is what I prefer, is because if you do that, all of a sudden your mock is out of date with the actual service API, and you're testing on stale data, or you're testing on a stale schema or something like that's not up to date. So that's a fairly sophisticated setup that is like a whole, like I can show you how to do that because I've done it before a few times. It works, but it's high maintenance. So if you can get away with contract testing, I suggest that you do that. Or for a smaller system, just use Docker Compose or some other setup script that sets up all your services on your laptop, run your tests as locally, and then save the real end-to-end tests where you actually run things, either if you're testing production or a QA style environment. Just focus on the stuff that is truly critical. Create a very sophisticated health check that checks the core features and run that on a fairly regular schedule. And you should, if your system isn't like super flaky inherently due to the architecture, be able to do that without a lot of flakiness issues, because your test suite is so small when it comes to that layer that it's usually not much of an issue. Have a great day.